here. Terrence Carter. Lee Carter. Lee. But now this is I'd like to introduce Mr. Terrence Carter. He's coming and bringing us not only some math on Mondays, but also he's coming through bringing his tech skills, starting out with some programming, some gaming. Um, guys have been learning a lot of cool stuff. And so, of course, math is the foundation of a lot of that stuff. I know people hate algebra and stuff, formulas, all this. Even when you're looking at the X, Y axis, all that kind of stuff, that's really how stuff moves around on the digital graphs and worlds that we see. So, get you guys his undivided attention for Mr. Terrence Carter.
Yeah, so hey, I'm Mr. Terrence. I am a software engineer, and I'm going to be helping you with this math lab right here. We're going over real quick. If you need some time, feel free to pause real quick, look them over just to see what you know already. So I hope y'all paused it because I'm gonna keep it moving so we can get through this. So here are the answers. So -1 plus -17 equals -18. We got 21 minus 13 plus -4 equals 4. We got -8 minus -7 minus -2 equals 1. -5 minus -4 plus 3 equals 2. And then we come down here to number 5, the weather question. One winter day, the difference between the warmest and the coldest temperatures in the United States is 74 degrees Fahrenheit. If the warmest temperature of 61 degrees Fahrenheit occurred in Arizona, what was the coldest temperature which occurred in Alaska? So you would take the 61 degrees Fahrenheit and minus the 74 degrees Fahrenheit, and that's how you end up with the -13 degrees Fahrenheit. All right, and so these are some standards of mathematical content. What we're trying to do is interpret complicated expressions by viewing one or more of their parts as a single entity. And so what that breaks down to being is that we want to simplify these formulas. We want to break them down so they're easier to comprehend. And SSC brought 2, use the structure of an expression to identify ways to rewrite it. So there's many ways to write these mathematical formulas. We want to write them in a better way so it's easier to see at first glance what the answer is or how to see it in a clearer manner. And some of the mathematical practices that we're going to go over is like making sense of problems and preserving them in solving them, and model them with mathematics and look for and make use of those structures. So what we're going to try to do here is be able to write numerical expressions for verbal expressions. And so that basically means being able to write out the numbers in like 1 plus 3 and be able to say 1 plus 3 and then go back and forth with it. And then evaluate those numerical expressions. So let's start off with writing these numerical expressions. Numerical expressions is a mathematical phrase that contains only numbers and mathematical operations. For example, 6 plus 2 divided by 1 is a numerical expression. Some of these numerical expressions contain multiplication. Multiplication can be represented in several ways, including a raised dot or parentheses. And so here's a couple of ways that you can show multiplication. You see here we got the 2 times 3 with the raised dot, and over here we have the parentheses around the 3, parentheses around the 2, and both of them in parentheses. These all mean the same thing. They all mean 3 times 2, which equals 6. All right, let's practice translating some of these. Translate 1 plus 8 divided by 3 into a numerical expression. I'll give you a little bit of time so you can pause and go ahead and do that on your own. And then let's move on. And you can see that 1 plus 8 divided by 3 is represented like this. And so you have the 1 with the plus sign and 8, and then the division sign and 3. Very straightforward. So now let's think about it. Let's identify the factors of this numerical expression of 6 times 11. And what verbal phrases represents addition, subtraction, multiplication, division? And so you might be thinking about like, well, what does that mean? So when you're talking about addition, you usually say, well, 1 plus 2. So that is the verbal phrase for it is plus. And then subtraction, you might say something like 5 minus 3. So minus is the word that connects subtraction with 5 and 3. So that's how you know, you're like, oh, okay, we got to take away. Take away is also another word we can use. Multiplication, sometimes it's just as simple as multiply 2 and 3. Or sometimes it's 2 times 3. Division, same thing. You can go like 9 divided by 3. And so there's a lot of words that you can use in between those. So keep those in mind. So let's check that out. We have right here 7 times 15 minus 2 times 9. I'll give you a second to write that out and see what you get. You don't have to solve it. You just have to be able to put this in numerical expression. And so right here, you can see the 7 times 15 minus 2 times 9. It's okay if you have like the x's for multiplication or if you have the parentheses, as long as you have the right symbols for it. All right, so now we're going to practice some grouping symbols. Grouping symbols are like parentheses. So if you want a certain part of the numerical expression to happen first, you want to put that in parentheses so you know that you're going to do these before you go on to do the other parts. So, for example, we're going to translate the sum of 5 and 9 divided by 2 into a numerical expression. If you already know how to do this, pause it, go ahead. But for the rest of us, we'll go ahead. The sum of 5 and 9, we put those in parentheses. And because it's the sum of 5 and 9, we know that it's addition. So we're going to make sure to do that first before we divide by the 2. In translation, we're going to put the 5 and 9 together above the 2 because this is a simpler way of showing division when you have one of those longer expressions. So it looks a little bit cleaner when you see it like this. But this still means the same thing as up here, where it's 5 plus 9 divided by 2 with the parentheses. All right. So we're writing another numerical expression. A person's handicap in bowling is usually found by subtracting the person's average from 200, multiplying by 2, dividing by 3. Marley's bowling average is 170. So write a numerical expression for Marley's handicap in bowling. Take your time, push pause, write it out. Then we will continue. So what was the first step to finding that handicap? We know it to be subtracting from the average from 200. Now, you can take a step back and ask why. Why was it first? How did we know it was first? Well, we knew it was first because of how it was worded in the word problem. We knew that we had to do the subtraction before going to the multiplication and the division because of the commas and how it was worded in the question. So let's continue on to temperature. To convert temperature in degrees Celsius to Fahrenheit, first you would multiply the temperature's degrees by 9, and then divide it by 5, then add 32. Now write a numerical expression to convert 37 Celsius to Fahrenheit. All right, so this one's a little bit easier. We got A, B, C, and D. Go ahead, hit pause, write it out. Let me know your answer. All right, we're back here. We know that the answer is A because it is the temperature, which is 37, times 9, divided by 5, and add 32. And so we know if we look at A, it's 37, which is the number of degrees Celsius, times 9, then divided by 5, then we add the 32. B over here does the 37 times 9 part correctly, but then adds the 5 and 32 before the division, which is incorrect. And then over here, we do 37 times 9 divided by 5, but then we're multiplying by 32. This is incorrect because we're supposed to add by 32. And then D is incorrect because we're multiplying by 5 and then dividing by 9, which is backwards. We're supposed to multiply by 9 and divide by 5 before we add that 32. All right, so now we're going into exponents. So an expression of a form of x to the n reads as x to the nth power. The word power is used to refer to an expression or a value or the exponent of the expression. So when n is a positive integer, the exponent indicates the number of times that is multiplied by itself. So for example, 2 to the power of 2 means 2 times 2, which is 4. If you add 2 to the power of 3, then you would have 2 times 2 times 2, which is 8. To evaluate an expression means to find its value. If a numerical expression contains more than one operation, then the rule is to let you know which is to perform first with order of operations. So for order of operations, we're going to first do the expressions inside the grouping system symbols, which parentheses. And then we're going to evaluate all powers, exponents. And then we're going to multiply and or divide from left to right, and then we're going to add and or subtract from left to right. And so easy way that I learned how to do this in school was please excuse my dear Aunt Sally, which was please the parentheses in the grouping symbols, excuse the evaluating the powers or the exponents, the E, my dear, multiply and or divide from left to right, Aunt Sally, which is adding or subtracting. Important to remember, the multiply or divide can go either way. So it matters which one comes first, from left to right. It could be the division, it could be the multiplication, but those can be interchanged. The same with addition or subtraction, they can be flipped. All right, so now that you know that, let's think about this. Explain how the order of operations applies when using the formula 1 over 2 times height times base 1 and base 2, B1 and B2, we'll say, to find the area of a trapezoid. We're going to take a minute here so you can think about that, figure out what you would do first, second, third, fourth. There's a couple of operations going on right here, so give you a minute to pause, and then we'll hop back into this. We'll evaluate each expression. So first, we would do inside the parentheses. So the B1 and B2 will be added. Next, we will check for exponents. We look here, we don't have any. And then next, we will check for multiplication and division. Well, that's all we have left is multiplication and division. So we would have the 1 over 2, and then we would times that by the height, and then we would times it by the combined B, which is the basis of the trapezoid. So after that multiplication is done, we would have the result, the answer from that formula. So no need to go for the addition or subtraction at that point. So we're going to evaluate each of these expressions. All right, so now knowing what we know, let's evaluate 20 minus 7 plus 8 to the second power minus 7 times 11. Hit pause, wait for it. All right, we got your answer. And what we would do is do the powers first, so 8 times 8. And then we would check for any multiplication. So bam, right here. We got 7 times 11. So we would multiply that. And then after that, we would just go down the line. So it would be 20 minus 7 plus the 64 that we got earlier from doing the powers, and then minus the 77 that we got from the multiplication. Bam. So let's think about this. Write an expression that uses exponents at least 3 different operations. Explain the steps that you would take to evaluate the expressions. So go ahead, write that out, think about it. And then we're going to write the steps of the order of operations in the correct order. So pause, make sure you remember all 4 steps. All right, so now we remember that we first start off with our parentheses. So evaluate those expressions inside those grouping symbols. And then we do our exponents, evaluating all powers. And then we do our multiplication and division, multiply and or divide from left to right. And then we do our addition and subtraction, adding and or subtracting from left to right. So if you got that, good job. If not, go over it again. You'll get it right. All right, let's look at this arcade. Melly is playing a bowling game at an arcade. She rolls 2 balls into the 30-point hole, 4 balls into the 20-point hole, and 3 balls into the 50-point hole. Write and evaluate an expression to find Melly's total score. All right, so we're going to write a whole complete table to write the expression of the Millie score, and then we're going to evaluate it. So first, let's put it all together first. So we broke it down into a table, breaking down each of those parts. So we have the 2 balls that are rolled into the 30-point hole, plus the 4 balls that are rolled into the 20-point hole, plus the 3 balls that are rolled into the 50-point hole. And so now we got to put those into expressions. If you have an idea already, go ahead, push pause, and you can write those into those blanks real quick and see if you fully understand and got it right. And we're evaluating those. And so go back here, we have the 2 times 30 plus the 4 times 20 plus the 3 times 50. And that's what we have over here. And so that's the 60, the 80, and the 150 that we add together to equal the 290 as our sum. Millie scored 290 points. All right. Let's look at this computers. A computer technician charges a flat fee of $50 plus $25 per hour. On Monday, he worked on Aika's computer for 2 hours. Sorry about that. On Tuesday, he worked on Aika's computer for 3 hours. So we want to break this down and figure out what parts of these are important to the question and how we should express this into a formula. So one thing we need to keep track on is this flat fee of 50. The 50 is going to be constant and it doesn't need to be multiplied by anything because it's a flat fee. The $50 is guaranteed and not manipulated. But this $25 is per hour. So we need to take note of how many hours total has been worked and multiply it by that $25. So on the Monday, we know that he has the 2 hours. And then on Tuesday, he worked for another 3. So if we want to express that, we would do that in a number of different ways. So let's look at these different ways and see which ones apply. So right here we have A, 50 plus 25 times 2 plus 25 times 3. So we have our flat rate of 50 plus the $25 an hour times the 2 hours he worked on Monday plus the $25 an hour times 3, the 3 hours that he worked on Tuesday. So yeah, A is correct. We go to B. B has the $50 flat fee. We got that. We got the $25. We got $25 an hour times the 2 plus 3. The 2 from Monday and the 3 from Tuesday. So yeah, This one also checks out. This is also correct. C, we have 25 with parentheses 2 plus 3. This is close, but this is missing the flat fee of 50 that is required. D, 50 plus 25 in parentheses of 5. That is correct because it just took the 2 hours plus the 3 hours that already happened and combined them before putting it in here. So it will still give you the same answer as A and B. And then E, 25 plus 50 times 2 times 3. This one's incorrect because of the 25 is not the flat fee. The 50 is. So they flip-flopped the 25 and the 50. And B, how much money does ICA owe that technician? So we would just have to do that math. So 25 times 5, well 25 times 5 is 125. Oops. Let me get my computer back. And then we add that flat fee of 50. So that will equal 175. Boom. If you got that on your own, good job, good job. All right, expressions with grouping symbols, aka parentheses. So we're going to evaluate each of these expressions. So we have parentheses, and then sometimes when you have multiple parentheses, they like to use these brackets. They work in the same way. Give you a second to work through those functions. Then we'll continue on. So we're going to evaluate inside the parentheses and then evaluate the power of the numerator. And then we evaluate the innermost parentheses, evaluate that power, add, subtract, and add. Yeah, so we always start with the innermost before going to the outer ones. All right, so that's something to think about. Equivalent expressions have the same value. Are the expressions 30 plus 17 times 10 and 10 times 30 plus 10 times 17 equivalent? Why or why not? Think about it. Get your answer formulated. The answer is yes. These answers are equivalent because that is what this is doing. So when you multiply when you add this and multiply it by 10, you get 47, and then 47 times 10 is 470. So when you add this, this is 300, and then you add this is 170. So then you add them together, you get 470. So they have the same value, therefore they are equivalent. All right, so we're evaluating this. Take a moment. Remember to check for powers before we start doing we have to do our groupings, checking for powers, and before we get into our divisions and additions and subtractions, and we end up with 1/8. How did we get there? We started with our power in here, and we found out that this is 8. 2 to the power of 3 is 8, like I said earlier. And then minus 5, that gave us 3 up there. And what you don't see in these types of functions is that these two are groupings, even though they don't have the parentheses explicitly shown. You always do everything on top, everything on bottom before you divide between each other. So you end up with 3 up there, and then down here you end up with 24. So you end up with 3 over 24. That can be reduced to 1 over 8, 1/8. All right, plan for problem solving. Use a 4-step problem solving plan that can help you make sense of problems and persevere in solving them. All right, so step 1, identify and understand the task. Read the task carefully and make sure that you understand what the question is, the answer, and the problem that you have to solve. Step 2, plan your approach. Choose a strategy. Plan the steps you will use to complete that task. Step 3, solve the problem. Use the strategy you choose in step 2 to solve the problem. And step 4, check the solution. Make sure that your solution is reasonable and completes the task. So something to think about. How can this 4-step problem solving plan help effectively solve problems? This is something for you to think about. So let's figure out this money situation right here. Thursdays are student days at the LSC theaters. Student tickets are $5 and popcorn refills are free. You buy a ticket and a 20-ounce bottle of water, and you'll split the cost of a large hot tub of popcorn and candy with a friend. So how much money should you bring? Give you a little bit to think about that. So first, we got to understand this problem. We are given what you will buy and the cost of each item. The cost of the popcorn, the candy will be split with a friend. We are asked to find the amount of money that will be spent. So the amount of money that we need to bring. So you can see here, mini tub is 3, medium tub is 5, large tub is $7.50. 20 ounce is $5. 32-ounce drink is $5.50. 44 ounce is $6. Fruit snacks is $3. Hot dog is $5. Candy is $3.50 for when it comes to snacks. So we have all these numbers, but we only need certain ones. So we have to make sure that we choose the right ones for this question. So now we need to plan. Write the expression to represent the total cost of ticket, drink, and food. Evaluate the expression to find that cost afterwards. So let's write this expression total cost in dollars. Let's go back to this question. So we have the $5 for the ticket. The popcorn refills are free, so we don't need to worry about that. So, and we're going to get a 20-ounce bottle of water. So remember that we're going to need that 20-ounce drink. And then we're going to split the cost of a large tub of popcorn and a large candy with a friend. So remember that we get the ticket, we got the 20-ounce drink by ourselves, but then we're going to split the large tub of popcorn and the candy with a friend. So now let's think about the order of operations to evaluate this expression. So we can figure out that the cost of the ticket and the water is $10. So 5 for the ticket, 5 for the 20 ounce. The total cost of the popcorn and the candy is $11 if we added those large tub of 175 and the 370, 750 for the large tub and the 350 for the candy. So that equaled the 11. So half of that cost, because we're splitting it with a friend, is $5.50. So the total is $10 plus that $5.50, which is $15.50. That's how much that you needed to bring to the movie theaters. So now let's do the same thing with these pets. So while she was on a 7-day vacation, Miss Hernandez boarded her dog at a kennel. If her boarding budget was $2.50, can Miss Hernandez afford a daily extra walk and one wash and nail trimming? So let's look at that. So we're looking over here at the services. We got the board, which is $24 per day. That's something that we have to do. We have to see if we can get this extra wash. Is what we're trying to figure out. So we need one of those washers. Extra walk is $4 per day. So that's something that we have to keep in mind. Nail tripping is part of the question, so we have to keep that in mind as well. The question didn't ask for vitamins, so we don't have to include that in our equation. So once we do everything and multiply the board times 7, the extra walk times 7, and add the wash of 45 and the nail trimming of 12, we total the 253. So the answer is no. The cost is higher than her budget of 250. All right, so let's look at this. Two friends evaluated 27 divided by 3 plus, in parentheses, 12 times 4 in different ways. So we're going to look at how they both did it, and we're going to evaluate who did it right. Ooh, I am missing that little bit of information. But even though I'm missing that, we're going to talk about what is the right way. So the right way is to do it in the parentheses first. So we have the 12 times 4, which was 48. And then by order of operations, we go back to the beginning and evaluate this 27 divided by 3, which is 9. So then we end up with 9 plus 48. 9 plus 48 equals 57. So the answer would be 57, which apparently Shakita got. All right, and so that brings us to the end of our lesson. I would like to thank everybody for showing up to the stream today at the Math Lab. Be sure to tune in next week for the next Math Lab at MPJ Academy. We look forward to hearing from you.